Hi friends, today we will see the difference between half wave rectifier and full wave rectifier. So first we will see different parameters. So the different parameters are definition, types, number of diode requirements, circuit diagram and so on. So we will see one by one. So these are the parameters. On these parameters we are going to compare or we are going to differentiate the half wave rectifier and full wave rectifier. So coming to the definition, what does mean by half wave rectifier? So an electronic circuit which converts half cycle of alternating current into direct current is known as half wave rectifier. So the rectifier term is the conversion. Actually the rectifier means it's a converter which converts AC into DC. Okay, so AC means there are two cycles, one off cycle, maybe positive off cycle and negative off cycle. So by using off wave rectifier we can get either positive or negative off cycle, okay, as the direct current. So that's why this is called off wave rectifier. Coming to full wave rectifier, an electronic circuit that converts the complete cycle of alternating current into direct current is known as full wave rectifier. That means in full wave rectifier, off wave is also coming and full wave is also coming. I mean, off cycle, positive off cycle is also coming and negative off cycle is also rectified. Okay, as positive off cycle is on always positive side, so it will be as it is coming as it is, but for coming to negative off cycle it has to be rectified. That means the negative off cycle should come as the positive off cycle only. Okay, that part we will see. So this is the definition between half wave rectifier and full wave rectifier. So coming to the types, half wave rectifier is having no further classification. It is having only one type, that is half wave rectifier. Coming to full wave rectifier, there are two types. One is center tapped full wave rectifier. Second one is full bridge rectifier. Okay, bridge full wave rectifier. So these two types are there. So coming to number of diode required. So in half wave rectifier only one diode is required, as we can see in the circuit diagram. Only one diode is required to make half wave rectifier. So coming to this full wave rectifier, we should definitely have two diodes. One diode for positive off cycle and second diode for negative off cycle. And the bridge full wave rectifier should have four diodes. Okay, and we will see why four diodes are required, even though we can get the same output by using two diodes. Okay, that part we will see in the differentiation only, we can see that part. So this is the some of the differences between half wave rectifier and full wave rectifier. Let us move forward to know some more differences. Yeah, coming to rectified cycle of AC. So in half wave rectifier, only half cycle of AC being rectified. This part we have already seen. So half part means either positive or negative. Okay, but coming to full wave rectifier, both the cycles are rectified and corresponding waveforms are also shown here. If I want to make only positive off cycle to be rectified, so it was rectified like this, but whenever negative off cycle is coming, it's not rectified and it is keeping it as a zero. Okay, so this is the output waveform of the half wave rectifier. So coming to full wave rectifier, so here negative off cycle is also transferred as the positive off cycle only. Okay, so it is rectified means whatever we are getting negative things, so that will be positive. So whatever things we are having, that should be on positive side, only unidirectional should come. So this is the perfect example for the rectification, complete rectification we can say, because it is full wave is rectified here. So this is the difference, basic difference between half wave rectifier and full wave rectifier. By showing the waveforms also you can see the difference. Coming to electric current through load. So the electric current through the load is not continuous. So you can see here it's not continuous, because if it is a positive half wave rectifier, whenever negative cycle is coming, in that case you are getting zero current, and vice versa. Whenever you are using negative half wave rectifier, so whenever positive off is coming, at that time you are experiencing zero current. So in this way you are getting a non-continuous current. Coming to full wave rectifier, a continuous current flows in the load because in off wave, whenever the source voltage is off wave, you are getting off wave. Whenever source voltage is negative, still you are getting off wave. So if the source is positive or negative, you are getting output. So that's why here the current is continuous. Yeah, this is very important point to be noted. So peak inverse voltage. So the peak inverse voltage for the off wave rectifier is equal to the maximum value of the input voltage Vm. First of all, we should know what does mean by peak inverse voltage. So if whenever you are giving supply and the diode is on, so there is no problem, the operation will continue. Whenever you are giving supply and diode is not on, that means diode is in reverse bias, so how much voltage it should appear across the diode, that should voltage has to be burned by the, I mean carried by the that particular device, that means diode or thyristor. So this part is very important. It is for off wave rectifier, it is simply VM, but coming to full wave rectifier, it is 2 VM. That means whenever the diode or the thyristor or device is not in conduction, how much voltage will appear across that device. Okay, so that is called peak inverse voltage. It is peak inverse voltage. That means whenever it is not in conduction, how much voltage it is appearing, and that to peak voltage, how much maximum value it is getting. So for off wave rectifier it is getting only Vm, for full wave rectifier it is getting 2 Vm. Okay, so for full wave rectifier it is getting 2 Vm. So because of this reason we are going ahead with the bridge rectifier. So if it is a bridge rectifier, still it is having 2 Vm, but fortunately we are having two diodes in conduction and two diodes in not in conduction. So these 2 Vm voltage was borne by two diodes. So each diode can hold only Vm only. Okay, so that is the advantage of bridge rectifier when compared to center tapped rectifier, simply making this difference equal. That means as in off wave rectifier we are getting peak inverse voltage Vm. If we use bridge rectifier in full wave rectifier also, we are getting Vm only. So to make it equal, so we are going ahead with the bridge rectifier when compared to center tapped rectifier. Otherwise we can simply say, yeah, it is peak inverse voltage is 2 Vm only, but we have to understand one thing. In bridge rectifier, two diodes are there, so two diodes are sharing this 2 Vm. Understood? So now we can say that whatever peak inverse voltage of diode is there, that is same when compared to off wave rectifier and full wave rectifier, if we use bridge type of full wave rectifier. Okay, otherwise we have to bond the 2 Vm only. For center tapped we have to go ahead with 2 Vm. So coming to output frequency, so how much will be the output frequency? For half wave rectifier, the frequency of ripple output is equal to the input supply frequency, that is F. Because in positive off cycle it is getting cycle, and in negative off cycle it's 0. Again next positive off cycle it is getting cycle, and negative off cycle it is 0. So if you see the frequency, it is exactly equal to the supply frequency. But coming to the full wave rectifier, in positive off cycle it is coming positive cycle, and in negative off cycle wave also it is coming as the positive off cycle only. So what will happen? So the frequency is doubled here. The frequency is double. So for normal one frequency, here we are getting two pulses. So that's why the frequency is doubled. So the frequency becomes 2f. Coming to maximum efficiency of rectification for sinusoidal AC. So what is the maximum efficiency? For half wave rectifier, the maximum efficiency of rectification is 40.6% only. Okay, 40.6% only. Coming to the maximum efficiency of the rectification for full wave rectifier is just double to that, 81.2%. Okay, 81.2%. Coming to ripple factor, the ripple factor for off wave rectifier is 1.21, and the ripple factor for full wave rectifier is 0.482. Okay, so we can see how the ripple factor can, I mean, how to calculate this ripple factor. And once you go ahead with the equations, so once you go ahead with the voltage and currents of half wave rectifier and full wave rectifier, you can easily identify the ripple factor. Coming to form factor, the form factor of the half wave rectifier is 1.57. Coming to the same thing, the form factor of the full wave rectifier is 1.11. The next one is peak factor. So what is the peak factor? So for half wave rectifier, the peak factor is equal to 2. The peak factor equal to 2. For the same peak factor for full wave rectifier is 1.414. Coming to transformer utilization factor. So the transformer utilization factor of a half wave rectifier is 0.2865. And the same thing for full wave rectifier is 0.692 for center tapped rectifier and 0.8106 for bridge rectifier. Coming to the cost, obviously the cost is less for half wave rectifier as we are using only one diode. Coming to full wave rectifier, it is obviously costly because we are using more number of diodes. Of course, diode cost is very less, still it costs more. Okay, comparatively it is more costly. So voltage regulation, so the half wave rectifier has good voltage regulation. Coming to full wave rectifier, the full wave rectifier is better than that of half wave rectifier. Okay, obviously voltage regulation is very good compared to half wave rectifier. Coming to the saturation of the core, so in case of half wave rectifier circuit, the DC saturation of the transformer core is common problem. It is very common problem, so it's somewhat difficult to handle. But a full wave rectifier doesn't have DC saturation of the transformer core at all. This is the advantage. So thank you so much for careful listening, and please like this video and please share this video with your friends and family, and kindly subscribe to my YouTube channel. If you have any more doubts, you can put it in the comment box so that we can go ahead. And meantime, after this, I will keep on adding the problems, okay, numerical problems, how these values have come. So exactly what does mean by all these values, all these factors. So those things I will discuss in my further videos. So I like to continue with the two courses now. One is power electronics and second one is electronic devices and circuits. So kindly follow my YouTube channel so that you can get the complete idea on these two courses. Thank you. Thank you so much.